Hello everyone, and firstly welcome very much to my video and thank you for having a look. I hope you'll find this interesting. I'm quite excited about it because I think it's something that's genuinely new and it will add to our collective understanding of how the science of stellar formation and planetary formation works. We all of us, scientists and non-scientists alike, will have seen the tremendous advances in the news where scientists and astronomers have been discovering thousands of exoplanets. That's planets that exist beyond our own solar system. And many of these planets in recent news have been popping up not fitting in with current planetary models. Now myself, I studied astronomy and physics at university 35 years ago, a long time ago, and I'm what you would call a non-scientist, and I'm presenting this video and this series of videos towards a non-scientific audience. My hope is that I would like to, what's the right word to use? I would like to try to democratize the process of looking at science. I think if you were to go back 100 years or so, people just in the general population could develop their scientific theories and actually add greatly to humanity's understanding of how the universe fits together. And I'm hoping that we can find a way to return to that, because if I, as a non-scientist, present these theories via a university or via a science research paper, many scientists will look at it and say, well, who's this guy? And why has he got something to say about this? This is our topic, not for him. And so my hope that by, I don't know if that's the right word to use, democratizing this process, my hope is it can become a lot more accessible for other people like me who are what you might call hobby scientists or amateur scientists. I'm also hoping, and this is where you, the audience, will come in, I'm also hoping that this new approach to launching a new theory, which is to launch it first on YouTube and first to the general population and allowing the scientific community, who I hope will benefit from and enjoy this theory and will develop it further, but presenting it first to the wider population, because I would like to use that method of presentation to fund my ongoing research. Now, I've done this, it's Sunday afternoon at the moment, the one short time I've got in between work jobs, family jobs, jobs around the house. Got a little bit of time to produce this, this video, but if I could fund my research properly, I could do a lot more detail. And the scientists and mathematicians amongst the audience of this will look at the derivations that I've used in the full theory and they may say, it's a bit arm wavy. Well, yeah, it is. I would like to make it a lot more detailed and a lot more thorough and rigorous, but it's quite hard to do that without adequate funding. And for me as a non-scientist to get funding, not really possible. So this is where you guys come in. If enough people will like this video and subscribe to the YouTube channel, and also when adverts pop up, if you click on them, apparently that generates advertising revenue effectively for the person that posted the video. So I'm hoping that by posting this video and some more detailed videos that will follow, I'm hoping to be able to fund further scientific research. Now, you, the viewer, that do click on subscribe, my hope is that you'll get a ringside seat as my other theories start to be developed. One of the other theories might be quite a lot of fun, and it's not at a stage yet where I can develop it or even really publicise it, but I have designed, we'll see if it works or not, I've designed a new type of rocket motor that I kind of should be able to make myself if I have the time and the resources. And if enough people will subscribe to this video, I can use the money that I get from YouTube or any other. I'm going to open an account with the platform X, because apparently people can make money on that by, sharing their ideas. So if that can make me some money, that will also go to fund this research. And those people that are subscribers or followers or whatever you want to call it, they'll get a ringside seat to that theory. And also, I have an idea to bring gravitational theories in line with the theory of relativity, which could be really interesting. And I want to also publish that in the same way that I'm publishing this, and hopefully fund that research with likes and subscribes. So that's why I'm launching this particular theory, or as you'll see in a moment, 3 theories via YouTube initially and via social media, because my hope is that I think other people make quite a lot of money using social media videos. My hope is that we can collectively fund the research that we all need and that we'll all benefit from using exactly this social media approach. So I've arranged for my television to show the image on this iPad, so I can then describe, initially in this short video, the summary of how this theory works, and then in subsequent follow-up videos I'll give you the detail and the mathematical derivations. And there are some really quite interesting things that come from it. One thing in particular, and those keen-eyed observers that are looking at the television screen there will notice that I am theorising there are 9 planets, or rather there were 9 planets in our solar system. And this big guy here, you can see the planet here, which is between what we now call Mars and we now call Jupiter. I'm calling it, after my own name actually, I'm calling it the planet Peter. Now I think the planet Peter will have had a mass significantly greater than the planet Jupiter. When you look at my derivations, you'll understand exactly why. This planet will have been composed, the majority of its composure will be hydrogen. It will have hydrogen and water and CO2 as Jupiter does, but it'll have a much greater concentration of it. And you'll understand also why Mars is smaller than its neighbours. So there's some interesting things in there. But in particular, I'm really excited about how, as I've been working on this theory, and it just kind of popped in my head after worrying me for the last 35 years, it's kind of, the solution just popped into my head. Since then, I've barely been able to open a newspaper without reading about exoplanets and why their existence is a problem, whereas my theory explains their existence isn't a problem, it's exactly what you'd expect. And then there's one final tantalising, and I really think it is tantalising, thought, and that is that this theory could, and this is not a proof at all, and I just want to be clear on that, but this theory could indicate why we have life on Earth and could indicate quite a lot more beyond that, which I find tantalising and a bit of fun. So, without further ado, please, by the way, everyone that's watching this video, please do click like, click subscribe, and if any banner adverts pop up, just click on them, even if you're not watching them, and leave them playing in the background, or even if you're going off and making a cup of tea, just leave them playing, because by doing that, you're funding scientific research. So yeah, please do click like and subscribe. My theory, which is a genuinely new theory, is as follows. There's 3 aspects to it, and they're on the screen here. The first aspect is that all collapsing bodies, all gas collapsing to form stars, all of those will form an accretion disk that will give rise to the formation of planets. Current theories explain that as planets, as the gas that forms a planet collapses, that the acceleration or the rotation speed will accelerate as the gas collapses, a bit like an ice skater on the ice spinning around with arms outstretched. When they pull their arms into the centre, they spin round much more quickly. I'm going to have to pause for a minute. I'm hoping that I can be able to edit these 2 bits together, because I had to pause because the family came back from Christmas shopping. So yeah, where I was at, oh yes, so the first rule is that all collapsing bodies, including protostars, including planets, including black holes, all collapsing bodies will experience a force. It's a thermodynamic force, which I'm calling a Brabenian force. Again, it's after my name. We'll have to see if those names stick. I kind of hope that they do. And I'll explain in the full theory how Brabenian forces arise from the thermodynamic effect of the gas collapsing, but they will automatically form the gases into an accretion ring, where the gases orbiting the body that they're collapsing onto will be on a disk, and the orbital speeds will be exactly right, so that each radius of matter will orbit in exactly a stable orbit. And although the forces themselves are not new, because this is thermodynamics, which has been around for the last 300 years or more, this interpretation of thermodynamics, which leads to accelerate gases as they collapse, I think is new. I've had a good look around the internet. I can't see it anywhere. So I'm calling it it's an implied force, a bit like centrifugal force isn't a real force. It's the reaction of centripetal force, or the absence of centripetal force. This is a similar sort of concept. And also within this aspect of the theory, I look at the motion of collapsing particles as they move along a net collapsing vector towards the centre. I'm describing the motion of those gases, again with my name. I'm calling it Brabenian motion, because a bit like Brownian motion in a static gas, it's the Brabenian motion of the particles as they're collapsing that accelerates a small component, and it's about 0.1% of the mass that's collapsing into an orbital velocity. So that's quite exciting, that's quite new. And the second part is possibly more exciting because what I'm saying is that all accretion disks will form planetesimals, small planets that will bolt together little bits of mass as they're orbiting around, and that those planetesimals will come together. Well, there's kind of nothing new here. What is new is I've used the quite simple mathematics of Lagrange, the famous mathematician, to use the Lagrange principles to calculate that actually always, as those planetesimals come together, they will come together in a final pair, and that final pair will be approximately opposite the star. And so as that final pair comes together, you will have a motion around the star where sequentially the last pair of planets will catch up with each other, and then centrifugal force will pull them apart, and then they'll catch up with each other the other side of the star. Centrifugal force will pull them apart. The instability, effectively the work done by the other planets and the other material in the solar system, will mean that that the energy of that planetary system will change, meaning that the orbit will get closer and closer until it reaches a distance of about 60 degrees away from planetesimal 1, from planetesimal 2. They'll then unstoppably come together, and that collision is what has shaped our solar system in the way that it is. And I'll say in the full theory how that explains the orbit of Mercury, because that shouldn't be there. It'll explain why Venus rotates the wrong way and why it doesn't have the right axis of tilt, and also why Venus has no magnetic field. It will explain why the Earth-Moon system came about. We know from detailed work and analysis that many astronomers and physicists have done. Whoops, there's my iPad timing itself out. Whoops. I have to see if I can edit this out. Where was I at? Oh yes, we've done lots of work has been done on the planet Theia, the theoretical planet Theia that came together with the pre-Earth, and the collision of those two bodies is what caused the Earth-Moon system. The problem that I've always had with that theory is it seems entirely plausible, but what are the chances of an Earth-sized or Mars-sized planet coming into our solar system to collide with the proto-Earth? Well, let's be honest, it's nil. If there were many large bodies like a Theia-sized body coming through the solar system, their mere existence would be perturbing the whole planetary disk in ways that we would see. So that's just not happening. So where did Theia come from? And the answer is Theia is Earth's final planetesimal partner. There's no question in my mind about that, and the Lagrange analysis will show that. So that's the second theory. Oh yes, and moving further out through the solar system, why is Mars as small as it is? Well, this theory predicts that Mars will have had a partner, which I believe was captured by the neighbouring planet, which we don't see anymore. And that, what we do see where that planet would have been, or approximately where that would have been, because orbits of planets will migrate, particularly when the star ignites its fusion process. Planets will migrate, but their planets will migrate in their orbits anyway. And so where the planets are in their orbits now isn't where they will have been, I don't know, 4.5 billion years ago. But the planet Peter, which would be between Mars and between Jupiter, would have been much larger. And I believe the planet Peter will have captured the main body of Mars, and I'll explain why in the full theory, because Mars has cooled really quickly, and its atmosphere is a lot thinner than any model would predict, and certainly a lot thinner than my model would predict. My model does predict the atmospheric makeup and the chemical makeup of different planets, dependent upon the chemistry and the mass and the temperature distribution of the star. The planet Peter would have been so large that it will have destroyed itself, as I'll explain in the third part of my theory. As you then move on to Jupiter, Jupiter again has a different axis of tilt to the other planets and a different axis of tilt to the Sun. Why is that? And again, this explains why that is. Saturn has a lot of material orbiting it high up. Late in its development, I can understand, and many theories show exactly why moons collide with each other and the tidal forces will produce a disk of sorts. When you then take into account the Brabenian forces using the model that I have, it's obvious why those disks will have arisen. But when the rest of the solar system was sweeping up all of its material, why Saturn still not swept it all up? And the answer is because the collisions that occurred, leaving all of that stuff in high and unusual orbits around Saturn, happened really late on. It happened at the time of what's referred to as the late heavy bombardment. And this is what shaped the surface of the moon that we see today. The late heavy bombardment has been analysed in great detail, and there's no cause for it. Well, this theory, the third part of this theory, explains the exact cause for it. As you go further out, the planet Uranus, I just love saying that, it's always going to be funny, I'm sorry, it is, but that planet is rotating the wrong way. The rest of the disks rotating like that, and you'd expect the angular momentum of everything to be the same, but it kind of goes the wrong way for Uranus. This theory explains why that is, of course. And then you get to the final planet in the solar system of Neptune. Neptune is really too big and too watery. Both of the ice giants are just way too watery for current models to explain, whereas it's not only explained by my theory, it's actually what you would expect from my theory. And then finally you have the, what would you call them, the objects of which Pluto is one, and there are many other named objects that have orbits outside of our planetary disks, and there's the other asteroid masses further out in the solar system, and their orbits I think are explained by the fact that far out in the solar system there are different gravitational pulls from nearby stars, from dust in the interstellar medium, and from the galactic centre itself. We know that our own sun is following a circular orbit around the galactic centre. So that's planet rule 3. I think explains quite a lot. And then you move on to rule 2. I'm getting ahead of myself. Rule 2 explains quite a lot. Rule 3 is when it starts to get when it starts to get fun. And what rule 3 says is that planets above a certain size and below a certain size will be much less likely to exist because they will annihilate themselves. And the planet Peter, which I estimate will have been about 3 or 4 times the mass of Jupiter, but I do need more data to accurately come up with that mass. And the data's available, actually, and once I can get hold of it, and hopefully this publication of this theory will encourage people that have that data to share it with me, and then together we can plot planet size by frequency of observation for the 5,000 or so exoplanets that we've seen. And I think what you'll see is around about 3 or 4 Jupiter masses, or somewhere around that size, you will see a dip. I'm calling it, I'm trying to put my name in things. Of course, rule number 2, which is that planets will form in final pairs, I'm calling that the Braben conjecture. We'll see if that sticks. Please let it stick. And then the rule 3, if you draw a graph of planet size and how often we see them, increasing sizes, increasing sizes, I think you're going to see a fairly straight line distribution, but there'll be a dip around about 3 or 4 times the mass of Jupiter. And the thing that will cause that is the same process that forms a star. As gases come together to form a star, as long as there's above 80 times or 85 times the mass of Jupiter, if that comes together, the pressure and heat given up by thermodynamics is so high that a fusion process will occur, and that fusion explosion will drive more fusion because you've got more pressure and more heat. Hydrogen atoms pushed so closely together that they form a helium atom and they release their binding energy. And by a happy coincidence, the gravitational mass of 85 plus Jupiters is enough to balance that explosion. So you have the fusion explosion and then gravity balancing it. And that's why we see stars in equilibrium. At lower masses than 85 or so masses of Jupiter, you still can have enough pressure and temperature to drive fusion processes. You can, for example, lithium will fuse together at lower pressures, and deuterium. will also fuse together at lower pressures. But similarly, the explosive force of those explosions is even down to 10 times the mass of Jupiter. You can have a fusion process going, but there's enough mass to balance that. When you have smaller planets, there's not enough mass to drive the fusion process and to kick it off. There might be enough mass to kick off a fission process where big, heavy, rocky elements are quite far into the solar system, elements that have got enough heavy, rocky mass, enough uranium and other types of big atoms that can split apart. If you get enough of that material together, just like an atom bomb, they will blow apart, and that explosion could drive hydrogen fusion. But more likely, it's going to be the enormous gravitational pressure and temperature. Now, when you get the two halves of planet Peter coming together, each of those is twice or so the mass of Jupiter. You've got all of that crushing pressure of the mass, plus the gravitational potential energy of effectively nearly a third of an orbit coming together with an enormous bang. That pressure will be enough to ignite a fusion process. But there's not enough gravitational mass to hold it. So the explosion products that come out will have a velocity greater than the escape velocity of the mass of that particular planet. And so as we draw that line, you'll find at a certain point, there'll be a dip in the probability of a planet having that size. And I'm going to try and call that the Braben dip. And that gives the three theories. And then I will do another video. I'm going to do a video on each of these theories where I'm going to go through the mathematics, and hopefully the scientific community will be kind and look at my analysis as a non-scientist. But that will enable a thorough analysis of the theories. And then I'll produce another video, which I think will be really good fun. It's going to theorise where life on Earth might have come from. And if that conjecture was true, how might we know? And I won't bore you on this video because this is already quite long. Yeah, I'm looking at the time. This is already too long. So I won't mention it on this video, but I will mention it on the subsequent videos. So hopefully you will find that very exciting. I find it exciting. So just to wrap up, thank you for watching my video. I hope you have enjoyed it. Please fund my further research by clicking on like, clipping on subscribe, and if there's any adverts pop up, click on those. Please also forward it to anyone that you know that might watch it, because if enough people like and subscribe or watch it multiple times, then the advertising revenue it will generate will allow me to produce more of these videos, and more importantly, more of this research, which I'll happily share with everyone. And hopefully it can be a fun journey. So thanks for your attention. Like and subscribe. Do it now. Yeah, now please. Yeah, click on like and subscribe now. And thanks again for your time.